question number 12 is saying, when a boy weighing 20 kgf sits at one end of a 4-meter long seesaw. That means this is a 4-meter long seesaw. So its pivoted point will be at the middle. So one of the side will be 2 meter, another side will be 2 meter. So when the boy weighing 20 kgf sits at one end, so the boy is sitting here at 20 kgf, it gets depressed at this end. Definitely it will come down. How can it be brought to the horizontal position by a man weighing 40 kgf? So the man must sit at the opposite side here. So W1 is given 20 kgf and W2 is given 40 kgf. So according to principle of moment, we have to know that anti-clockwise moment equals to clockwise moment. So anti-clockwise moment means it's W1 into D1 and clockwise moment it's W2 into D2. So W1 is 20 kgf here and D1 is 2 meter because he is sitting at one end. W2 40 kgf given and D2 we have to find, that means at what distance the man should sit to bring it in the horizontal position. So if we simplify this, you will be getting as D2 equals to 1 meter. Because 20 to the 40, it will be cancelled. So D2 will be 1 meter. So your answer will be, man should sit at a distance 1 meter from the center of the side opposite to the boy. This is the answer. Now the question number 13. A physical balance has its arms of length 60 centimeter and 40 centimeter. So though the physical balance should have both the arms of equal length, but still here is given one of the arm is 60 centimeter, another is 40 centimeter. What weight kept on the pan of the longest arm will balance an object of weight 100 kgf kept on the other pan? That means we should find out what weight should be kept on the longest arm here, that is at 60 centimeter arm, so that it will be balanced by the 100 gf weight which is kept on the another arm, that is 40 centimeter, the smaller pan. So what weight kept on the pan of the longer arm will balance an object of weight 100 gf kept on the other pan. So here this is the other pan where 100 gf is kept and this is kept on the shorter arm. We have to find out the weight, that is we have to find the weight of the longer arm. So we know that according to the principle of moments, clockwise moment equals to anti-clockwise moment. So this is the anti-clockwise moment and this is the clockwise moment. So W1 distance is 60 centimeter and W2 is 100 gf into distance is 40 centimeter. So it's if we simplify this, W1 will be equals to 100 gf into 40 centimeter by 60 centimeter. So if we cancel it, so after simplification, we will get it as 66.666, which can be also written as 66.67 gf is the answer. Now the question number 14. The diagram given here showing a uniform meter rule weighing 100 gf pivoted at its center. That means the weight of the meter rule is 100 gf and it's pivoted at the center O. Two weights 150 gf and 250 gf hang from 2 points A and B respectively of the meter rule such that OA is equals to 40 centimeter and OB is equals to 20 centimeter. Calculate the total anti-clockwise moment about O. So this is the anti-clockwise moment, as we can see here. This is the anti-clockwise moment. So formula we know, it's weight into the perpendicular distance. So 150 GF is the weight and 40 centimeter is the distance. So 150 GF into 40 centimeter, it will be 6000 GF centimeter. Second part which we have to find, that is a total clockwise moment about the point O. So this will show the clockwise moment. So total clockwise moment about O will be again the same formula, force into the distance. So 250 GF into 20 centimeter. So it will be 5000 GF centimeter. The third is the difference of anti-clockwise and clockwise moment. So just we have to subtract 6000 minus 5000. So it is coming 1000 GF centimeter. Fourth point is the distance from O where 100 GF weight should be placed to balance the meter rule. So since the anti-clockwise moment and clockwise moment, they are not equal, so that means the ruler is not in equilibrium. So we have to place the 100 GF additional weight here. So additional weight 100 GF if we have to place, then at which side we should place, we have to see first. So here we can see the clockwise moment is less. So to balance it, if this is 6000, so here 1000 more moment has to be there. So that means we have to add the additional weight over in this side only. So same formula again, the anti-clockwise moment will be equals to clockwise moment. So 6000 will be equals to, this is 5000 plus additional weight is 100 GF and distance we have to find. That means at what distance it should be kept. So it's 6000 minus 5000 equals to 100 into D. So 1000 equals to 100 into D. So if we simplify, so D will be getting 10 centimeter. So your final answer will be additional weight to be placed at a distance of 10 centimeter on the right side of O, because we have to place it here only. So this is your answer. Here the question number 15 is, a uniform meter rule of weight 10 GF is pivoted at its 0 mark. This is the uniform meter rule. So its length should be 1 meter. So 0 centimeter here and this is 100 centimeter. And the weight of the meter rule is given, it's 10 GF. So at the center of gravity, that means at its midpoint, the whole weight will be acting. So here 10 GF weight is acting and its pivoted point is 0. So the rod is fixed at this point, it can rotate about this point. So here if the weight is hanging, so here it will be moving in the clockwise direction. So the first question is, what moment of force depresses the rule? What is the moment here? So moment we know, the force into the distance. So force is 10 GF and distance is 50 centimeter here. So it's 500 GF centimeter. So now it has depressed because the weight is acting here and this is the free end. So it has depressed at this point. So how can it be made horizontal? By applying a least force. So this is the clockwise moment. So here we can write, the direction is also showing here, it's clockwise. Now the least force has to be applied at a maximum distance. So maximum distance is 100 centimeter. So to apply the least force, we have to apply the force at a distance of 100 centimeter. So according to principle of moment, clockwise moment equals to anti-clockwise moment. So clockwise moment which we have already got, that is 500 GF, and anti-clockwise moment, so it has to be the distance we already have, 100 centimeter into this weight we have to find. So if we simplify this, we'll be finding it as 5 GF. So but we cannot apply the force in this direction, but because if we apply the force in this direction again, so it will be moving clockwise, but we need to produce the anti-clockwise moment. So that is why we have to apply the force in the upward direction. So when we will apply the force in the upward direction, it will be moving in a anti-clockwise direction. So the weight of 5 GF which we have to place at this end, So we will place it, we will apply the force, hence 5 GF force to be applied in upward direction. So this is your answer. Now this is the question number 16. A uniform half meter rule can be balanced at 29.0 centimeter mark. Half meter rule means its length will be 50 centimeter and it can be balanced at 29 centimeter mark when a mass of 20 gram is hung from its one end. So since the balancing point is not the midpoint, so at the midpoint its whole weight will be acting. So here this is the force, this is the weight of the meter rule, half meter rule, which is acting. So the weight of 20 gram is which is acting, that is acting over at this end. But here we have to be careful about the unit. Here mass of 100 gram is given, but the force will be acting here, the weight will be acting here. So weight formula W, we know it's m into g, we know this formula. So that is why whatever is the mass here, that is 20 gram, that is to be multiplied with g, and here so m into g has to be there because mass of the rule into acceleration due to gravity. So this will be producing anti-clockwise moment and this side will be producing clockwise moment. So what we have to write, let the mass of the half meter rule be m. So anti-clockwise moment equals to clockwise moment by the principle of moments. So here m into g, that is W into distance it has to be. So m into g, distance from here it's 4 centimeter. And another side it will be 20 into g and the distance is 21 centimeter here. So this g and g will be cancelled and 4 5s are 20. So m will be equals to 21 into 5, that is 105 gram. So we are finding the mass here. So this is the second part of the answer. The first part was draw a diagram of the arrangement, which we have already drawn, and second, find the mass of the half meter rule. Third is in which direction would the balance point shift if 20 gram mass is shifted inside from the one end. That means if the 20 gram mass has to be shifted in the middle, so that means this balancing point also has to be shifted towards 25 centimeter mark. So these are the answers.